Hi, welcome to another video on differential equations. Today we're going to be talking about the unit step function. Oh, unit step function, so cool, right? Wrong. No, I'm just kidding. It is cool because the Laplace transformation is usually for, or most often, if not always, used on piecewise functions. Okay, so that's something to keep in mind about Laplace transformation. So if you see here, we have a piecewise function. It is a graph of piecewise. Okay, so basically these are the piecewise functions. Okay, to my past self, where the past video where I told myself I couldn't make these brackets. I made them. They took me quite some time. But I made them. They look really nice. So yeah, if we see here, we have piecewise functions. And essentially what we're trying to do is, if we had a piecewise function, well, how do we Laplace that? We haven't seen that yet, but what we need to see is that we can turn a piecewise function into something that we're more familiar with. And here we have our unit step function. So if we take this information and we plug it into this equation, we're able to Laplace it, basically. So this is one of the equations that you have to be familiar with. Okay, so if we Laplace a function with its unit step, what we do need to consider is, does the argument of this function and the unit step match? Need to match. All right, so these need to match. So this is t minus a, this is t minus a. Great. So we can proceed and we get to pull out an e to the negative as. Now the unit step is different because when we Laplace it, we get this e to the negative as. Okay. And then we're left with the function t of, function t. We need to Laplace that function t, whatever it is. Okay? So one thing you have to consider is that the Laplace of the unit step function is equal to e to the negative as divided by s. And a cannot, where a is greater than 0, I'm sorry. All right? So these are two equations that you do have to remember for unit step functions. So let's continue using this idea of unit step in a problem, because unit step will solve our problems. Maybe not all our problems. All right, so let's start off with this problem, which is number 26. We have the Laplace of 3t plus 1 unit step t minus 3. All right, so this definitely has to be t minus 3, right? This has to match with this. Right now they don't match. So they need to match. How do we make it match? Well, we can't just like shove them in like Tinder or whatever dating site. So let's match them some other way. So the goal is t minus 3. T minus 3 seconds. Sorry, I had to say that. So we can make this 3t minus 9 plus 10 unit step t minus 3. Okay? Well, we just manipulated this. This is the same thing as that, right? So negative 9 plus 10 is 1. Well, 3t plus 1, same thing, right? We're just manipulating it. So if we look here, we'll have the Laplace of 3t minus t minus 3 plus 10. So what I did was basically just looked at that, factored out a 3 from this, and I got 3t minus 3 plus 10. Unit step t minus 3. Okay, so, well, it looks like our arguments are the same. Okay, so what will I do now? Well, what I'm going to do now is I'm going to multiply this unit step. Where am I going to multiply it? Here and here. So I have 3t minus 3 unit step t minus 3 plus 10 times unit step t minus 3. All right. So that looks like something we're going to deal with. Okay. So what I'm going to do is I'm going to take out that 3, right? I'm going to have also a e to the negative 3s Laplace of the function f of t. So it's only t because I've already taken out this 3, this negative 3 here, right? So I'm just left with the t that I have to deal with now, plus 10e to the negative 3s over s. Because like we said, the Laplace of the Laplace of the unit step function, the Laplace of that is going to give us e to the negative as over s. A is greater than 0, right? So we're Laplacing this 10u, right? Okay, so now we have 3e to the negative 3s. That is going to be s squared. So we could say s squared plus that is 10e to the negative 3s over s. And we just solved this unit step function. And there's our answer. Wonderful. All right, so let's look at another problem, which involves trig. Yay, more trigonometry. Sine t, unit step of t minus pi halves. Oh, great. So when I look at this, I know I'll probably have to use one of my identities, right, to get this argument the same as this. They're not the same right now. However, we're going to match them. Will they ever find their match? I don't know. Let's see. I'm going to use the sine A plus B. Okay. And this is going to mean sine t minus pi halves plus pi halves. All right, and I'm going to treat this as my A, treat this as my B. All right. So then I'll have sine t minus pi halves cosine pi half plus cosine t minus pi half sine pi half. Okay, well, if I look here, cosine of pi half, well, if I think about my unit circle, maybe I didn't memorize it in trig. Oh, I should have memorized it. Well, cosine of pi halves, that goes to 0, right? And if I think back to trig, oh, my unit circle, sine of pi halves is 1, okay? So now I have, whoa, 0 times all this, wipe out, that's gone. So now I'm just left with that over there, times 1, so that's great. All right, so great. Yeah, that goes to 0. Okay, so if I didn't make it clear, the sine t is what I was using to manipulate. So this was sine t minus pi halves plus pi halves. Well, that's just sine t, as I have there, right? So I'm trying to make this the same as this argument. And now, ta-da, they're the same. So now I can Laplace them. All right, so I notice negative pi half. That's going to be my e to the negative pi half times s, right? Let's see. And then we're going to Laplace that function t, which is cosine of t. And now, if I do this computation, I have e to the negative pi half s. This one's going to be s over s squared plus 1. And that's going to be my answer. So we basically use some more scary trig. Don't be afraid. Okay, so let's look at a more involved problem. Okay, this one looks pretty simple. All right, this t is t minus 5, this t is t minus 5, great. So let's continue. Well, we can't, because this t is not t minus 5. Great, that one t is not t minus 5. So this is what we're going to do. More manipulation. How do we manipulate that? Well, we're going to do it like this. This is how we're going to do it. This is all the same. No problem. No problem. So now, if I were to basically distribute everything, I'll have t minus 5, e t minus 5, unit step, t minus 5, plus the 5e t minus 5 unit step t minus 5. Okay? So if you look at that, I'm basically taking this and distributing it to that, right? And then since it's addition, I just split it up, took the plus separately. All right, so wow, all my t's are t minus 5s. Woo, that's great. So now I'm going to pull out an e to the minus 5s, Laplace t e to the t power plus 5 e to the negative 5s, Laplace e to the t, okay? We're still good, no problem. No problem at all. All right, so no problem at all, great. Now we have e to the negative 5s. Now here comes another one of our, this is our special function, right? Because we can't Laplace something that's being multiplied, right? So we're going to have to go back to the idea of absorption. That t is going to absorb that e to the t. So we're going to be left with the Laplace of t. But when we get our s's, that's going to go from s to s minus 1. Okay, whoa, back to that idea. Great. Well, that is simply 1 over s minus 1. Great. That was easy. No problem. Okay. It's just that one we had to remember about the special function. So that's going to be, let's see, that's cubed. Yep. Yep. So e to the negative 5s. That's 1 over s. S will go from s to s minus 1. Great. So s squared, I'm sorry, plus all that. And then I have e to the negative 5. We put that s minus 1 into those s's. Plus 5. All right, so basically what I did was just like ultra simplify. All right. If you can't see the answer, I'm not sure if your professor will want you to ultra simplify, but this is the simplified version. Okay. Great. Maybe some more on unit step. This should be a quick one. All right, so if I see this, e to the negative pi half s, that tells me that I'm going to have a unit step, right? That's going to tell me that. So I'm going to pull that unit step out. And I'm going to Laplace inverse whatever's left. Okay, no problem. Unit step t minus pi half. That's going to be cosine 2t, right? However, our arguments don't match. Well, now they're arguing because they don't match, right? So we need to make them match. This t will go to t minus pi half. And that's how they'll match. So the unit step, t minus pi half, cosine of t minus, 2t. And now they match. There you go. And that's how you're supposed to leave it. Okay? All right, so let's perhaps do one more thing. Here's a theorem. Here's a theorem for basically derivatives. We haven't seen anything where derivatives are involved. So this is where the derivatives come into play. Right here. Okay, so if I had so if I had this function, if I wanted to Laplace this function, t of power n times a function of t, well, there we go. We're multiplying functions, right? So we can't really do that just yet. When I say just yet, there's something coming in the future. Right, so we can't do that just yet with using Laplace by itself. So what we're going to do is multiply by -1 to the n power, whatever that n is in our function, times the derivative to the power of n, whatever it is, and then we're going to Laplace that function t that's left over, okay? And what do I mean by that? Well, here we go. We're going to utilize it right now. So the Laplace of t hyperbolic sine 3t. Whoa, we haven't used hyperbolic trig function, so here we go. That's not 3. There we go. Well, our power is 1, but we don't see it. So that's going to be negative 1 to the power 1. That's the first derivative, right? Of natural, sorry, I keep saying natural log. The Laplace of sine h3t. Okay, so all we did was plug all our information into that theorem. So our n was 1, so that's just the first derivative. Wait till you get the third power, which means you'll have to take the derivative, the triple prime, right? No problem, no biggie. You can take triple derivative. All right, so we'll have the hyperbolic sine of that 3, so that's going to be 3. So we're going to take a first derivative. It's going to be negative, right? So the derivative of this, that's going to be negative times negative 3 s squared minus 9 quantity squared times 2s equal to positive 6s over s squared minus 9 quantity squared. So hopefully your derivative skills are proficient. All right. And so that's how we deal with multiplication in this sense. All right, so that will end this video. Hopefully you were able to learn something. If you have any problems, you could stop the video. You could also comment. Thank you.